Quad Output Integrated MOSFETs Power Supply MC34700 by Freescale Semiconductor. Welcome to the training module on Quad Output Integrated MOSFET Power Supply. This training module gives overview operation of the device and its application areas. The MC34700 is a compact high-efficiency power supply with on-chip power MOSFETs that feature 3 step-down switch and regulators and 1 low dropout linear regulator. The switch and regulators utilize voltage mode control with external compensation, allowing flexibility in optimizing the performance of the MC34700 device for a given application. The device is ideal for space-constrained applications where multiple power rails are required and simplicity of design and implementation of the power supply is necessary. The MC34700 is well suited for power supply designs in wide variety of applications, including set-top boxes, cable modems, laser printers, fax machines, point-of-sale terminals, small appliances, telecom line cards, and DVD players. When power is first applied to the MC34700, the internal regulators and bias circuits need to be up and stable before the power on reset or POR signal is released. The POR waits until the gate drive regulator's voltage has reached about 4.0 volts before it allows the rest of the internal blocks to be enabled. Each regulator has an independent enable pin. This allows the user to program the power-up sequence to suit the application. As each regulator is turned on, it will execute a soft start ramp of output voltage. This is done to prevent the output voltage from overshooting the regulation point. Without a soft start ramp, the output voltage will ramp up faster than the control loop can typically respond to, resulting in an overshoot. This is the functional diagram of the MC34700. It consists of an analog circuitry which includes a VDDI regulator, band gap, and power on reset. Others are logic and control blocks which enable inputs, supervisory logic, current monitor, thermal monitor, and a power supply block which has an LDO and DC to DC converter. There are 3 different modes of operation: normal mode, standby mode, and fault mode. The MC34700 monitors the regulators for several fault conditions to protect both the system load and the IC from overstress. An overvoltage condition occurs when the output voltage exceeds the overvoltage threshold. To avoid false trips of the overvoltage monitor, the power good circuit has a 10 microsecond glitch filter. Once the output voltage falls below the overvoltage threshold and back into regulation, the fault is cleared and the power good signal goes high. A current limit condition for the switch and regulator occurs when the MOSFET acts as a current detection device by sampling a fraction of the current in the power MOSFET. This sampled current is compared to internal reference, which determines whether the current is exceeding the limit or not. The temperature of the power MOSFET in the switch and regulators and the LDO are monitored using a thermal sensing transistor located near the power devices. The devices have 4 outputs, namely DC or DC1, DC or DC2, DC or DC3, and an LDO. DC or DC1 is capable of generating a 2.0 to 5.25 volt output at 1.5 amps. DC or DC2 is capable of generating a 0.7 to 3.6 volts at 1.25 amps output. LDO is capable of generating a 0.7 to 3.6 volt output at 400 milliamps. The MC34700 has independent inputs for each regulator. This allows a high degree of flexibility as far as how the IC can be configured. Only buck converter 1 has 9 to 18 volt input range. All other regulators have 1.5 to 6 volt input range. Some sample configurations are shown, and all the regulators require an input voltage higher than the output voltage. They can be connected in either single or dual input supply configurations. The compensation network consists of the error amplifier and the external resistors and capacitors. If designed properly, the compensation network will yield a closed-loop transfer function with a higher crossover frequency and adequate phase margin to be stable. Choose the closest standard value for the compensation components. It is recommended to use a mathematical model to plot the closed-loop response. A more intuitive representation of the mathematical model is an asymptotic Bode plot of the buck converter's gain versus frequency is shown. The open-loop error amplifier gain bounds the compensation gain. When the MC34700 is configured for cascaded operation, where the output of one regulator powers the input of another regulator, the startup sequence also needs to be cascaded. The output voltage of the first regulator needs to be up and stable before enabling the downstream regulation, otherwise startup overshoot can occur. If the application requires a simpler implementation of the cascaded sequence startup, a single enable signal can be used to start the first regulator in the sequence. When sequencing the regulators on, one parameter that must be considered is the leakage specification. This is a typical application circuit diagram.